The APP approach builds a rounded picture of students over time based on activities and conversations. Let's see what Tom Pull, Head of Maths, gleans from 2 lessons investigating angles.
Just have a look at this video, and what I want you to think about is what maths can you see in the video. We're doing a mini project which is part of our APP process and is essentially an in-house kind of rich task that we've developed with the idea of trying to get a better idea of where students are. A rich task is the sort of activity where there's a number of paths that the students can take and it can lead them to different answers in the end. The idea is that the curriculum comes first and the assessment comes out of that curriculum, so that we're not just sticking assessment on at the end. I'm going to tell you one little fact about pool tables. However the pool ball hits the table side, okay, so hits the cushion there, it will bounce off at exactly the same angle. We're just going to look at how the ball behaves after 2 bounces off the cushions. The important thing is up to you what you're going to do. If you can see some maths that you know about, that you think's really difficult maths that you want to show off about, then go down that way and experiment with that.
All the angles that we're using here add up to 90 degrees.
Okay, can you use any angle facts to explain why that is? A lot of them, what they're doing at the moment is just noticing that the 2 angles add up to 90. What I want them then to do is reflect that back into the angle fact and see that that relates to the fact there's a 90 degrees in the corner. Can you add anything to that diagram that might help you then with angles if you know you're working with a square?
Triangles.
Huh?
Triangles.
Triangles. Okay, so we're talking squares and triangles now. We've got a square there, and you can see some triangles. That's the direction you should be heading in terms of trying to explain what's going on. It's an essential part of APP because of the fact that if they can explain to me that it's 180 degrees in a triangle, they're showing me a level 4 skill there, essentially. And verbally is enough for me. They've said it to me, so I know they've reached that point yet.
Whatever angle that is there, then it's going to be the angle that is bouncing off that. So AA.
The bouncing around that the students kind of do in the first lesson is all about the conflict they're having. There's a conflict behind kind of them coming up with ideas and not being sure if they're correct. And so there's a confidence building kind of element there. The bouncing around is experimenting, seeing what works, what doesn't, making hypotheses about what they think is going to happen, and then trying practically to see. What if we didn't know what that angle was? What if that angle was N?
You work it out.
If a student gets kind of stuck and pinned down by a concept, I'm quite happy to let them battle with that concept for the hour, and maybe they don't get miles into the mini project, but because we're doing this over and over again throughout the year, we're going to get a picture in other places. Okay, Adam, tell us what you're doing then.
10 plus 80 equals 90, and
Right.
40 plus 50 equals 90.
Right.
And I found out the nth term, so the nth term would be n plus 90 minus n. That would equal 90.
Fantastic. Now, what I'm really interested in here, okay, is that you've been going around and you've been changing the angles, which is absolutely fantastic. But now you're starting to think about, what if I don't put a particular number down, but instead I put down n? Could you try drawing out your diagram, but instead of putting numbers in that diagram, could you try putting those angles that you've started there? Because you've certainly started it, but it'd be nice to see it in a diagram, and then maybe I'll be able to see what other kind of patterns is coming out from that. That's fantastic. Heading into algebra, absolutely brilliant. That's where I want you to head. I'm holding back very much, so I'm just trying to push them in the right direction when I can. But at the same time, if I can, what I'm trying to do is get the students to explain to each other what's going on. So if they ask me a question, what I'll often do is defer that question to somebody else on the table. Okay, good. So you've noticed that there's a pattern going on here where you've got this alternate going on. And you've also noticed that n plus a equals 90.
Sir, I think, you know, this is Adam's method.
Right.
I think it's like the same as mine because you've got n plus here and 90 minus n is another number. And if you could just call that A.
Oh, this is really interesting because what you're doing there, right, and that's absolutely fantastic, okay, is you're doing what's called algebraic substitution. Okay, so you've noticed that this actually looks the same as this. Yeah, and look, you've taken that 90 minus n, you've said that's great stuff. That's really high level algebra that you're doing there. I'm really, really impressed. I expected them to use some algebra, But what I didn't expect was for them to start coming up with different formulas and then comparing them and then being able to see that they were actually the same algebra after all, which was great, because there was an element of algebraic manipulation in there, and part of something that I've not taught them yet, that they started to come to grips with themselves.
I don't really understand how it's n take away and 90 take away n.
It's because the n you've got, if you take it away from 90, would make a number add n equals 90.
Can you relate it back to her diagram here? Can you show what's going on with the diagram?
I think it's definitely better than doing tests, because you get to interact with other people around you, and you get to because Mr. Poll actually comes up and gives you kind of clues, and it really helps you a lot.
It helps me understand my assessment levels, because it knows how to improve on which areas of teaching you need to improve on within these challenges.
It makes me a better mathematician, because you have to really think about why, and he helps you, but he doesn't give away the answer, so you've got to always do a bit yourself.
What I'm trying to do here is reflect on what the conversations that I've had with certain students in the lesson. I'm then going to have those ideas about what's been said to me, and what I want to do is I want to relate it back to the level descriptors that we've got, and when I'm in the next lesson, use that as a way of perhaps, when I'm talking to a student, see if perhaps I can